there's a tape machine in the camera at the moment, so I can't actually show you, but I think everybody's familiar with Mini DV, and we can play out Mini DV on this machine by using an adapter. We feed the tape in there and close it up, and then the machine thinks it's a larger cassette. And below the tape machine we have a simple audio mixer which takes all the external inputs, line level and mic level.
Why is channel 6 taped up?
It's faulty. The trouble with the mixer being there is that not everybody closes the lid when they finish with it, and things get dropped on, coke gets spilt on it, and I think it's actually physically damaged that fader at the moment. Right, and going over to the right-hand rack, top unit is an analog satellite receiver. We occasionally use it when we're not on our normal satellite. We're on, say, a telecom satellite or something. It's actually a check that we're on the right satellite. We know what frequency a particular station should be on that satellite, so we make sure we're receiving that satellite, that station. That's like a confirmation that we're on the right satellite. And below that we have a standard off-air television receiver. Below that is a waveform. It's a sync pulse generator and pattern generator. Produces all these different test signals, and it produces the ident that you can see when I go to bars. Now below that, in this rack here, oops, not supposed to do that. It's actually broken. The actual hinge is broken. Here we have the two A to D converters for the two analog inputs. Because everything is routed in the truck at SDI, you have to first thing that the signal has to become digital as soon as it comes into the truck. So these are the two A to D converters that convert external 1 and external 2 into digits. It won't close now. Below that, additional monitors. We've got. This is looking at external 1, looking at external 2, or the two tape machines, depending upon on the switch. And below that is our second tape machine. This is an older analog format, BATC. It's based on beta, on the old domestic beta format, and it's what we used to use before we went over to digital. But it still use a lot for editing purposes. So we still get a lot of material into the truck on beta. So that's why we have a second machine. Below that are the audio and video patch panels. The top two panels are program audio, all the sources into the switcher, and the one below that's mainly the comms, the communications signals. Then you have the video circuitry. The purple leads are purple U-links are SDI, and the white ones are analog. If you're trying to overpatch something because of a problem, you have to figure out, are you in the analog domain or digital domain when trying to mix and match there. You have to be a bit careful. And below that are the that's the mains control panel. We can run off external supply or generator supply. The generator, move my cases out of the way. Below that you have the generator display, and there's a changeover switch between the two.
How long can you run on the tanks that you have?
Easily a day. Oh yes. And over on the right are the controls for the generator, start and stop, and fuel level, water temperature before and after the radiator, and oil pressure.
How much does it all weigh, actually? You know, when you're driving it, what's the tonnage of the vehicle?
It's about 4 metric tons. And the final rack, which is probably the one that most people will be interested in, is the RF rack. Starting from the top, we have UHF radios. We have 2 receivers on 442 megahertz. These are used around London for receiving the clean feed. We have a setup. We have transmitters on the main mast at Croydon, South London, and also on the London Weekend studio roof. Sometimes we use radio as opposed to getting the communications over the satellite because you get less delay. And above that, this is a transmitter and receiver that we can use to feed the reporter. The reporter carries a radio like this, and he has an earpiece that he plugs into his ear, so he can hear the clean feed coming back. And normally this would be tucked away out of sight, so you wouldn't see it. Below that we have a RF patch panel. Below that we have a spectrum analyzer. We use this for actually finding the satellite. We're on 2 flights, 3 at the moment on this particular channel. This is our signal coming back off the satellite, and you can see just to the right of it, I think you can see the comms carrier. That's my 64 kilobit outgoing comms carrier. And if you go up to higher frequencies, you'll see this signal here. This is the downlink. This is actually transmitted from the signal originates from ITN, and it's the feed to the Leon receive site that carries Euronews. So any news stories happen in Britain, they are fed out on that link for Euronews. And above that, you can see these are the comms carriers. There's one of those per uplink, so we have to tune into the correct carrier there when establishing circuit. And if we go back, you can see we're getting a bit of breakthrough from an analog signal because we're so close to Astra. Astra's on 19.2 and we're on 21.5, so we're getting a bit of spillover from an analog signal on Astra. So that's what those spikes are there. Now below that, we have the antenna control. We can control polarization, azimuth, elevation. It's not automatic at all. We have to get a compass out when arriving on site and get some idea of where the satellite is and point it in the general direction, and then look for look for the beacon on the spectrum analyzer. Below that we have the comms modem. This produces an output on 74 megahertz, which is mixed with the 70 megahertz from the encoder, so it produces a signal 4 megahertz above my center frequency, and that's why you get that accounts for the spike there. That's 4 megahertz above my center frequency. Below that is my up converter. I'm sort of doing this the wrong way around, really. So perhaps I should start down the bottom, really, of the bottom of this rack. This is the NDS now Tamberg MPEG encoder. It's also a decoder as well, and the modulator. Now this modulator, Wrens might recognise the front panel of this. I remember something in PI6ALK that had exactly the same front panel, some error-free data equipment, but this is I don't know whether the NDS buy this from error-free data or not, but it's got exactly the same front panel. So the SDI video input and the analog audio inputs come into here, and compressed, in this case, down to about 5.6 megasymbols per second, and the output is 70 megahertz, which then goes to an L-band converter, which is controlled here, and to a block-up converter, which is actually on the roof, and we actually dial in here the frequency that we finally end up on coming out of the block-up converter on the roof. So that's 14.364 gigahertz. So that goes then to 2 HPAs that are on the roof. You can't see them, they're under covers, unfortunately, but they're controlled here in these two units. We're producing about 50 watts at the moment. Each one's producing 50 watts, but we're only using one of them at a time. You see here, A is going up to the antenna, and B is going to a load. So we have a hot spare, so we can immediately switch over to the other one if we have a failure. It always gives a monitor here of the helix current, because that's a very sensitive measurement, a critical parameter for travelling wave tubes. We've got to be very careful that the helix current is within limits. Well, I think that's a quick overview of the truck. I can actually listen to the output of the repeater. So if anybody wants to give me any questions, I'll have a listen.